Hi guys, good evening. Hi guys, good evening. Can you hear me?
Yes, sir.
Hello. Yeah. Thank you.
Good evening, sir.
Yeah. Thank you. So let us start session. Yes, yesterday class. One second. Yesterday class. Yes, discussed. Yes, let me mute all. Yes, yesterday class introduction. System software, application software, OS, front end, back ends. These things discussed. Languages. Yes, interpreter, compiler. Discussed. Interpreter and compiler. Main difference. exe file. These 2 points. Main difference. Interpreter. It will not generate exe file. Executable file. It will not generate. Compile if no errors in the program, then it generates exe file. It always executes only source code. Executing source code directly, exe file executes. Interpreter based language don't have exe file. Interpreter based language don't have exe file. This is main difference. Interpreter based language don't have exe file. Yes, here every program converts in exe file. Here everything is exe file. Yes, compiler based everything is exe file. Here all are exe files. Yes, always working exe file. Compiler based always exe file. Yes, interpreter based directly our code executes, source code executes. So interpreter based language don't have exe file. Yes, compiler based everything is exe file. Now that's okay. Interpreter and compiler difference is discussed here. Now what is Java? Java depends on what? Let us see about Java. It's Java. Yes, about Java. Yes, about Java. Yes, Java. Java. So Java is it? Yes, interpreter based. Yes, interpreter based or compiler based. Interpreter based or compiler based. That we should discuss. We should discuss that. Okay, Java. Yes, Java. Yes. Is it interpreter based or compiler based? That we should discuss now. Okay. Yes. Yes, names of interpreters. Yes, interpreters. These are names of interpreters, famous names. Yes, Python is interpreter. Python interpreter based. Python interpreter. HTML. Browser is the interpreter for the HTML. Browser is an HTML interpreter. JavaScript. Browser is an interpreter. Shell. Linux shell is interpreter. They're interpreters. Next, compilers. C compiler, C++ compiler, .NET compiler. Okay. Yes, compilers don't have any names. C language compiler, C language GCC compiler. That name is GCC. C language GCC. C++ also GCC. Okay, C and C++, Turbo C compilers, and GCC compilers. .NET name itself .NET compiler. Okay. Yes. Now let us see Java. So what is about Java? Yes, Java, is it interpreter based or compiler based? Let us see. See, except Java, in other languages, what happens? In other languages, what happens here? First is source code, your program source code. Source code converts into binary 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 code. Except Java, other languages, source code converts into binary code. That binary code given to processor. So processor taking binary code and generating output finally. Source code to binary codes. That may be interpreter or compiler. Okay, if it is interpreter based language, interpreter converts the source code to binary code. Suppose if it is compiler, if it is compiler based, the compiler converts source code to binary code. Either interpreter or compiler. Only one thing involving either interpreter or compiler. Either interpreter or compiler. That's a case of except Java. Except Java other languages. Except Java other languages here. Except Java, yes, in other languages. What happens here? Source code converts into binary code. Source code converts into binary code and given to processor. Then finally generating output. Finally generating output. This is what is happening. Yes, other languages. This is what is happening in other languages. Okay, one second. Why facing these guys? One second. One second. Yes. Next in Java, what happens? Let us see about Java here. Suppose same thing. If it is Java, what happens? Java, what happens? Java. Yes. Let us see Java. Let us take Java example. Suppose test folder. Here, some test.java file is available. Test.java. CMD command prompt. Command prompt. D drive. Yes. CD test directory. CLS. Yes. DR. Here this is test.java file. Yes, one second. Del star.txt file. Yes. Notepad. First writing Java program. Yes. Notepad. Test.java. Notepad. Test.java. Test.java. See. Public class test. Yes. Here it's a hello world. Simple program. Just hello world program. Save. Exit. No compilation. See here. Program. Your program. See like this. CLS. DR. Now you get test.java file is a test.java file. Test.java file. Now Java C test.java. Now it's compiling. It's compiling. Compiles. After compilation, check it. Yeah, this is dot class file generated. Dot class file generated. Yes, now dot class. Now running dot class test. Java test. Java test. Series hello world. Hello world. Now what's happened here? So first source codes means the .java file source codes. First of all, source code converts into a source codes. Compiler checks for all the errors. Yes, Java compiler checking for all the errors. If no errors, generating one dot class. That dot class file contains for byte code. Source code to byte code, not binary code. Source code to byte codes. Source code to byte codes. That binary code next level converts into binary codes. Next it converts into binary codes. After converting into binary code, this is given to processor. Yes, processor generating output finally. Okay, now what is happening here? There are two steps, two stages. See, except Java in other languages, maybe Python or C or C++, except Java, other cases, source code directly converts into binary code. Source to binary code directly. Source to binary code directly. But in Java, what happens here? First of all, source converts into byte codes. Byte code converts into binary codes. That binary code given to processor. So here some intermediate code is introduced here. In Java, some intermediate code here. Why this is introduced? To make the Java as independent platform. To make the Java as independent platform, that intermediate code is introduced here. Yes, between source code and binary code. Yes, there is a intermediate code. Intermediate code is a byte code. Why this is introduced here? To make the Java as independent platform. To make the Java independent platform. To make this Java as independent platform, bytecode was introduced. Bytecode was introduced. Let me explain. Let me explain. First, let me explain. Topic not completed. Let me explain. So source code converts into bytecodes. Bytecode converts into binary codes. Then given to processor, then generating outputs. Now who will convert source code to bytecodes? So first converting source code to bytecodes. Who will convert this? Which one will do this here? See this first. CLS. First we are compiling Java C tester Java. Java compiler. Java compiler. Result is but dot plus. Dot plus. Java compiler converts. Java compiler. Yes, it's a source code. Java compiler working on source codes. Source code to bytecode by the Java compiler. So this is Java compiler parts. It's a compiler parts. It's a compiler parts. Compiler parts. Java compiler generates. Okay, right? Next bytecodes. Now you can runtime. Yes, Java test. Java test. To run bytecode here, it converts into binary code. Who will do that? Interpreter. This is interpreter. So this is Java compiler. This is Java interpreter. There are two things involving here. First, error checking by the compiler. Yes, program execution by the interpreter. So next step is interpreter here. So next, yes, bytecode to binary codes. Bytecode to binary codes. Bytecode to binary codes by the interpreter. So this is by the interpreter. Yes, interpreter. So bytecode to binary code by the interpreter. Next, this part by the compiler. This part by the compiler. Yes, what happens here? Yes, Java errors checking, checking by the compiler, errors checking by the compiler, errors checking by the compiler, Java errors checking by the compiler. Yes, if no errors, 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 yes, if no errors, it generates bytecodes. If no errors, yes, it converts, it converts, it converts source code, it converts source code, it converts source code, it converts source code to bytecode. Yes, what is bytecode? I'll explain. If no errors, it converts source code to bytecodes. Okay, next. Yes, program. Yes, runtime. Program execution. Java program execution. Execution by the interpreter. Execution by the interpreter. So interpreter will execute. So interpreter. Execution by the program execution by the interpreter. So runtime by the interpreter. See errors checking by the compiler. Errors checking by the compiler. If no errors, it converts source code to bytecodes. Next, program execution by the interpreter. So interpreter taking bytecode, converting it to binary codes, and given to processor. Okay, see here. For example, use a test.java file. Yes, our case test.java. Test.java file. Test.java, it's a source code. Test.java. Test.java is a source. So this is source. This is source code. Okay. Test.java, it's a source code. Source code. Yes, this is yes given to Java C Java compiler. It's a Java compiler. Test.java that will be given to Java compiler. Java compiler generate taking that code here. Test.java compiling, checking for all errors, checking for all errors. If no errors, generating one tested.class file. Generating simply tested.class. Generating tested.class. Test.class. Now this is bytecode. This is bytecode. This is bytecode. Generating bytecode file. Tested.class. It's a bytecode. Okay. Now this tested.class file. This bytecode file. This bytecode file. So this is bytecode for now bytecode file. So now this is bytecode file. Dot class bytecode file is given to interpreter. This is interpreter. Java interpreter. Okay, bytecode file given to interpreter. The test.class file given to Java. Means it's interpreter. Yes, interpreter. Given to interpreter. Given to interpreter. Okay. So bytecode. This byte tested.class file given to interpreter. Interpreter taking that. Yes. Now bytecode file. Yes, interpreter Java interpreter taking bytecode file line by line converting into binary codes. Yes, line by line converting into binary codes and giving to processor. Finally giving to processor. So process line by line giving to processor generating output here. So here this step is compiler. This step is interpreter. Okay. So program errors taken by the compiler, program execution by the interpreter. Okay, errors taken by the compiler. If no errors, generating dot class file. After generating dot class file, if no errors, generating one dot class. Dot class contains bytecodes. What is bytecode? We'll discuss. Wait. What is bytecode? I'll explain. Okay. Now that the bytecode file given to interpreter, Java interpreter. So interpreter taking bytecode file, converting into binary code, line by line converting into binary codes, and given to processor, then execution. So what is happening here? Errors taken by the compiler, execution by the interpreter. So Java depending on both compiler as well interpreter both here. So Java depends. Java depends on both compiler as well interpreter. Compiler as well interpreter. Actually, compiler as well interpreter. Java depends on compiler as well interpreter. Just here some question for you guys. You guys try to understand it. Yes, try to understand topic here. Next question, understand the question. Next answer it here. See here compiler interpreter difference. This one interpreter based language don't have exe file. Interpreter based language don't have exe file. So interpreter based language don't have exe file concept, right? Okay. See here any language. One second. See once again. Yes. See any language. Yes, any language. Any language runtime. Any language runtime is an interpreter based. Any language runtime is an interpreter based. Interpreter based. Okay. See any language runtime is an interpreter based. Yes, interpreter based. Don't have exe. Don't have exe. That already we discussed. Interpreter based language don't have exe. Any language runtime. Any language runtime is an interpreter based. No exe file concepts. No exe file concepts. Now let's come to Java. Yes, Java language. Java language runtime is an interpreter based. Java language runtime is an interpreter based. Now question is here. Is there any exe file concepts Java? That is question. Or can we create exe file in Java? This is question. Yes, what's your answer? Say yes or no. Answer is either yes or no. Yes, what you understand now here? As per explanation of what you understand. Can we create exe file in Java? Yes, is there an exe file concept? See here very clearly explains. Any language runtime is an interpreter based. If runtime is interpreter based, no exe file concepts. If program runtime by the interpreter based, here no exe file concept. Java runtime is interpreter based, not compiler. It's a runtime is interpreter based. Java runtime is interpreter based. See, runtime is interpreter based, don't have exe file concepts. Now, same point here, Java runtime is interpreter based. Now, as per this, since Java runtime is interpreter based, now question on Is there an exe file concept in Java, or can we create exe file in Java? Yes, answer is either yes or no. Can we create exe file in Java? See, have you seen anywhere exe file here? In this first we have compiled Java program. We got the dot class file. After comparison and executed, right? So dot Java file is a dot class file is a dot class file directly executed. Have you observed anywhere exe file in this? In this process, Java program compiled and executed. Have you seen? Yes. Have you observed any exe file here? No. No exe file. No exe file. No. No very exe file. Just dot Java is the dot class. Dot class is not exe file. Dot class. Dot class is not exe file. Dot class is different. Exe file is different. Yes, exe dot class we'll discuss now. The clear topic is exe file dot class file only. Okay. Yes. So can we create exe file in Java? No. There's no concept of exe file in Java. Okay. Yes, no concept of exe file in Java. Java don't have the exe file concept here. Yes, Java. Yes, don't have exe file concept. Java don't have exe file concept. Java don't have the exe file concepts. Yes, everything is dot class file. Everything. Yes, everything is a dot class file. Dot class file. Yes, here dot class file is not exe file. Dot class file is not an exe file. Is not an exe file. Exe file is different. Dot class file is different. Exe file is different. Dot class file is different. We'll discuss. We'll discuss same point now. Now see this. Same explain document. See the documents. Yes, running notes is not necessary. Very clearly explained here. See, yesterday's that all that interpreter compile differences. Yes, very clearly prepared all the differences. Today topic. Java depends on both the compiler as well interpreter. Okay. Yes. In Java, errors checking by the compiler. In Java, errors checking by the compiler. If no errors, then compiler generates a dot class file. Dot class file is a bytecode file. It's a bytecode file. Yes, Java runtime by the interpreter. Java runtime by the interpreter. See what is happening in Java. Yes, source code given to Java C compiler, Java compiler, generating bytecode file. That bytecode is given to Java interpreter. The steps. Yes, Java interpreter, right? Java interpreter. Yes, converting to bytecodes. That bytecode to binary codes and linking to OS library. Now this we'll discuss today. Finally, generating outputs. Today we'll discuss about linking. That linking topic today we'll discuss now. Okay. Yes. Now see this. Source code to see the steps like this. Source code to bytecode to binary code, and process then output. See, source code to bytecode by the compiler, bytecode to binary code by the interpreter. So Java depends on both the compiler as well interpreter. Java depends on both compiler as well interpreter. Okay. Java runtime is interpreter based. Okay. See, any language. Yes, any language runtime is an interpreter based. No exe file concepts. Since Java runtime is interpreter based, no exe file concept in Java. Runtime is interpreter based. No exe file concept in Java. Here question is here. Can we create exe file in Java? No. There is no concept of exe files in Java. Yes, in Java everything is a dot class file. Everything is dot class file. Dot class is not exe file. That's it. So this is yes about interpreter to compiler. Java depends on compiler as well interpreter. So this is just Java introduced. Okay. Now Java features. Java is independent platform. Oh, let us see about this one here. Yes, very interesting point. This is very interesting. Very interesting topic. This is yes. See Java. Yes. Interesting. This is 1 second. Yes, here see Java is an independent of platform. Java is an independent. Java is an independent of platform. Okay, what does mean? Yes, what does mean here? Yes. So for Java feature, Java is an independent platform. What does mean? Okay. Here independent platform means OS. Platform is OS means independent of OS here. So what does mean here? Java program running on anyways. On anyways. The Java program running on anyways. The same Java program, same Java program. Okay, same Java program running on anyways means independent of OS, independent of platform. Same Java program. Suppose tested dot class file created. That tested dot class file running on anyways. Anyways, the market, all the operations. So same Java program running on anyways. That is independent of platform. Yes. No question. Immediately question is how Java made us independent of platform. This is important. Okay, so generally here, anyone says that independent of platform is independent of operating system. Okay, independent of platform is independent of OS. That is working on any operating system. That point anyone says, that definition anyone says. But how Java made us independent of platform? This is important. Yes, it's an interrogation. How Java made us independent of platform? What is concept behind of this? What is concept behind of this? Let us see. To understand this one, first of all about exe file. Yes, first of all you must have the exe file knowledge. Exe file. Yes, here's some question for you guys. Some question for you guys. Exe file. Yes, exe file prepared. Exe file prepared on yes Windows OS. Exe file prepared on Windows OS. Can I run on Linux base? That is question. Yes, that is question. Exe file prepared on Windows OS. Question is exe file prepared on Linux base. Sorry, exe file prepared on Windows OS. Can I run on Linux base? Okay, so exe file prepared on Windows OS. Can I run on Linux base? Everyone says that no. Yes, correct. So exe file, no, we can't. Reason. What's the reason here? So what's the reason here? So what's exe file prepared on Windows base? Can I run on Linux base? Answer is no. Answer is yes. For this answer is yes. Answer is no. Answer is no. For this answer is no. Why? Reason. Why? Reason is exe file is a OS dependent. Yet this answer everyone says. Exe file is a OS dependent. Yes, since exe file is OS dependent, we can't run on other operations. Exe file is a OS dependent. Reason why exe file? Yes, Windows based exe file cannot run on Linux base. Windows exe file prepared on Windows base that cannot run on other operations. Why? Reason exe file is a OS dependent. Exe file is a OS dependent. Here reason is exe file is OS dependent. Yes, immediately question why? Why exe file is a OS dependent? This is the question. Yes, why exe file is OS dependent? This point is very important. Why exe file is OS dependent? This question, yes, how to answer? For this purpose, you must have the exe file knowledge. What is exe file? Exe file contains what? No exe file. Yes, exe file contains what? Exactly what is exe file? Exe file contains what? Exe file contains this is. So what is exe file? What does it contain? Anyone says that binary code. No, that is not binary code. That is general answer. What is exe file? Means exe file contains binary code. That is anyone says. Yes, even who is having little bit knowledge in software field also, you can say that exe file is a binary code file. That is common answer. But exactly what is exe file? Exactly what is exe file? Okay. See, for example, here C program. Yes, C C program exe file. C program exe prepared on this space. On this space. Then it contains. Okay. Yes, it contains what? Yes, let me show practically. Yes, C starting launching C. C. See here math.cpp file. This program is math.cpp. 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 Okay, math.cpp. Math.cpp file. Yes, backend. Yes, yeah, that backend Turbo C is Windows based C language. Windows based C language. This bin contains all the program files. Math.cpp. Math. Yes, here math.cpp. Math.cpp. Let me remove these files. Yes, this also removed. So math.cpp. This is your program. Edit and see. This is math.cpp file here. Okay, that CP file. CPR, CP both are same. No compile. Let us compile this. Just I'm compiling Alt C. Alt C. Just compiling. Compiles. Compiles. See when compiled, what's happened here? Here some math.obj file generated. Properties. See .obj file generated. .obj file generated. Yes, see 8:39 p.m. just now generated. 18th November 8:39. Just now timestamp. Check the timestamp. Date modified. Timestamp just now generated. So object file generated. Math.obj file generated. Yes, after that. No. Yes. Run on the program. Enter key. Program executed. See this. Now this file generated 840. Yes, what application means is exe file. Application means exe file. Properties. See math.exe. So exe file generated, right? Yeah, this topic yesterday already explained. So exe file generated, that exe file running 10, 20. So got the outputs. Okay. Now how that exe file generates? At the time of creating exe file, what happens here? At the time of creating exe file, what happens? What happens here? Yes. C program exe file prepared in this space, then it contains here. Yes. Binary codes for C program. Okay. Yes. See here. This is math.cpp file here. Math.cpp. For this, after comparison, result is what? Math.obj file. .obj file. Binary code for C program. Nothing but say .obj file. The .obj file. That obj file. .obj file. Plus. Next here, there are some includes like the C library. For this header file, there is some object file. This header files also having object file. Like your C program, these also having object files. See stdio data. These also developed in C language. C library also developed in C language. So these header files also having some object file. Means binary codes. So binary code for C program plus binary code for yes, binary code for yes, C software like C library, binary code for C library, binary code for C library. So C library obj here are same .obj file. .obj that std.io data file is obj file. Binary code for C program, that object file, binary code for C library plus binary code for OS library, binary code for OS library. Okay, OS library extension .so. Okay, OS library extension .so files. Okay, by linking all of these things here, generates exe file. Yes, linking binary code for C program, binary code for C library, binary code for OS library. By linking all of these things, generating exe file. That exe file contains what? OS library. Now here it's a Windows OS library. Here Windows. C program exe file prepared in Windows OS. Then it contains binary code for C program. Yes, next binary code for C library and binary code for Windows OS library. Windows OS library. That means Windows OS library linked with exe file. Windows OS library linked with exe file. It's a statically linking. It's a statically at the time of creating exe file itself linked already. Linked. See, 1 second. Previous class we discussed one point here. Yes. See this. Every program has to link with OS library. Every program has to link with OS library before going to start execution. Yeah, these programs linking with OS library. While linking with OS library, yes, we communicate with hardware components. See here, with the help of library, communicates with hardware. Okay, C program, C++, Java, these programs, application software directly cannot communicate with hardware. To communicate with hardware here, all the programs have to link with OS library. So once linked with OS library, using that OS library communicates with yes input output devices, communicates with hardware. So while linking with OS library to communicate with hardware components, yes, in case of C language, what happens here? In the case of C language here, at the time of creation of exe file itself, yes, creation of exe file itself. 1 second. Yes, let me show that concept also. That exe. Yes, what is exe? Exe contains what? In Linux you can see practically. Yes, in Linux you can see very clearly. I'm starting Linux space. Yes, try to understand clearly. Actually, this kind of concepts nobody will explain. I'm sure it's my challenge also. It's my challenge as no trainer will explain, no website in the world will explain here. These concepts nobody will explain here. Who is having embedded C knowledge, they can explain. Okay, they can explain embedded C experience, they can explain. See that on Linux, embedded C programming and Linux based generally. See, Turbo C, this is for learning purpose. Turbo C just for learning purpose, but not for real time. Learning, C programming learning, real time is Linux based. Linux based. Yes, that embedded C. Yes, see. Here, yes, you guys don't think about Linux base. Our topic is not Linux base. Our topic is I'm explaining about C compiler. CD, mnrow directory, change of directory, yes, ls, remove t star, yes, remove t star, yes, remove star dot show, remote, see gedit, just like a Windows notepad, Linux notepad, gedit editor, edit means editor, yes, test.c editor, open, not the C program. A equal 10, B equal 20, C equal to A plus B, addition, subtraction, multiplication. Okay. Yes, here this is stdio data header file, included header file. Next C program. This header file is also has its own object codes, binary code. This header file also having its own binary codes. Now, compilation, GCC test.c. Okay. This is C language compiler. GCC -C is option. GCC compiler. It's the ANSI compiler. This is Windows based Turbo C. This is Turbo C compiler. This is ANSI compiler. ANSI, American National Standard Institute. ANSI compiler. Compiled. No error. See that? Test.2 file generated. Test.2 file generated. Test.2 file generated. No errors. No errors. Generated one test.2 file. Not GCC-O. Yes, next projects. Projects. Test.2. See, this tested.2 contains binary code for our C program. Binary code of our C program. Tested.2 object file contains binary code for our C program. Now, what is project? Project is a result exe, result file. LS series project exe file. This is the exe file name. Result exe projects. Project is a result exe. A green color means exe file. Linux green column is exe executable file. Now running this dot slash projects. Yes, execute. That exe name. That exe name can be anyone. Suppose in case of projects, suppose Durga. That name I can use. See that Durga. It's exe file. Okay, dot slash Durga running. Yes, addition, subtraction, multiplication. Now what's happening here? See this here. Yes, what is happening here? Now here this is to create exe file. At the time of creation of exe file, the GCC compiler taking binary code for our C program, binary code for C program, next binary code for C library, stdio data center file. Yes, here, yes, in this test.c program, this is stdio data center file. That stdio data center file, that library binary code, C library binary code plus C program binary code plus OS library. By linking all of this and generating on project exe file. Now this project exe file is linked with Linux OS library. Linux OS library. See here, C program exe file prepared in Windows space. Yes, now next another example. Yes, C program exe file prepared on Linux space. Now Linux space on Linux space. Then it contains binary code for C program. Yes, there is a .o file. Yes, binary code for C library. This is also same .o file plus binary code for yes Linux library. Binary code for Linux library. Linux library. That's it. So that Linux library linked to your exe file. That exe file contains for Linux OS library. Okay, exe file linked with Linux OS library. That means at the time of creation of exe file itself, at the time of generating exe file itself, OS library linked. OS library linked and generated. At runtime using that library. At runtime using that library. At runtime what happens? I'll explain. Wait. Now in Linux here, this is a file command. File project series. So file command checking type of exe. Sorry. File command is to check the type of file. Project. What is project? What's the type of this? See, executable file. Yes, 64-bit. Yes, this OS is 64-bit OS. Yes, Linux OS is 64-bit OS. 64-bit executable file. Executable next x86 means what? 8086 processor. Yes, my system processor 8086. 8086 processor here. Okay, next here, see lib64 ld linux .so.2. Dot is a version, the library version. Yes, S4.1, S4.2, S4.3, S4. That library version here. Okay, this is Linux library. The project exe file, project executable file contains what? Linux library. Okay, see this. You see this linked. See here, linked. Okay, linked with this SO file. Okay, linked. So this project exe file, project exe file is linked with the .so file, means Linux library. That's it. That is finally exe file here. So that is exe file. Now how this yes working of exe file, let us see. Okay, yes, C program exe file prepared in Linux OS here. It contains Linux OS library here. Okay, next one more example. Another example, C++ EX, C++ program. C++ program exe file prepared in yes Windows OS, then it contains binary code for C++ program. Okay, same .obj file. Okay, binary code for C++ library. C++ library something like iOS team data center file. iOS team data center file like this. So this object file. Next binary code for Windows OS library. This is C++ exe file. That means every exe file linked with OS library. Every exe file is linked with OS library. That is about exe file. Okay. Now let us take different platforms. That exe file working on different platforms. For example, here, for example, test.exe file. For example, test.exe file prepared prepared on Windows OS. On Windows OS, then yes, it is linked with yes Windows library. Windows library. Now this test.exe file, yes, working on different operating systems. How it works here? Let us take different platforms here. Yes, different platforms. Yes, platforms. Hardware. First hardware. Yes, hardware. Hardware. Yes, on top of hardware. Next, there is a OS. This is a Windows OS. Yes, Windows OS. So Windows, suppose Windows 10. Not Windows OS. Windows OS with Windows OS with Windows library with Win library with Win library. Sorry, Win library. Windows OS with Win library. Okay, Windows OS with yes, that Windows OS with Windows library. Okay, now test.exe file placing on Windows OS. Not test.exe file. Test.exe file. Right? So test.exe. Okay, now this test.exe file, suppose placed on Windows OS. How it's working? How it behaves at runtime? See runtime behavior. See test.exe file. When you try to execute test.exe file here, yes, it will try to call. It will try to call to Windows library. See here, test.exe file already linked with Windows OS library. Test.exe file prepared in Windows OS. Then it linked with Windows library. Okay, so runtime what happens here? Test.exe file. Yes, when you try to run it, it will try to call Windows library. Try to call Windows library. It will try to call Windows library. Okay, it will try to call Windows library. Yes, it's available. It's available. So here, so test.exe file calling Windows library. Using that Windows library, it communicates with hardware components. That's it. War successfully executing. Successfully executing. Okay. Now let us take another platform. Another platform. Another platform. Yes. Let us take another platform. Suppose same test.exe file, Linux platform, Linux platform, Linux base, Linux base with Linux library, Linux library, Linux base with Linux library, Linux base with Linux library. Okay, same test.exe file, same test.exe file, placing a Linux base. After placing a Linux base, try to execute. When you try to execute this one here, test.exe file, it will try to call to Windows library because library already linked. It's a part of exe file. OS library is a part of exe file. Okay, it's already linked. So now test.exe file, it will try to call Windows library, but here is not available. Yes, it's Linux library available. So this library, yes, not matching this library. So you get test.exe file, it will try to call Windows library, but here is not available. That library is not matching. Simply fails. Yes, here test.exe file, this has to communicate with the hardware components. How? It has to call to Windows library here, but it is not available. Library is not matching. Yes, library, call to library. Okay, library, call to library, Windows library, but not available. But the library calls is not available. Since it's not or simply fails. Library is not matching. Simply fails. Okay, suppose one more platform. Suppose Linux base. Linux base. Sorry, Unix base. Next Unix base. Unix base with Unix library. Yes, here also trying to call with yes. Here also test.exe file. Here also it will try to call to Windows library but not available. Yes, it is trying to call to Windows library but not available. Simply fails. Simply fails. So that's the reason exe file is a OS dependent. Exe file is a OS dependent. Here question is here why exe file is OS dependent? Dependent for this answer reason. Yes, it contains yes, it contains OS library. That's it. It contains OS library. Simple reason. exe file. It contains OS library. It linked. Yes, it linked. It linked with OS library. Okay, exe file. It linked with OS library. It linked with OS library. Since exe file linked with OS library, it's OS dependent. Since exe file linked with OS library, it's OS dependent. That is about exe file. Fine. Now let us come to Java. Yes, our topic now Java. Now you can understand very clearly Java how made us independent platform. Now you can understand. See Java. Let us come to Java. So what is happening in Java here? Yes, same example. Let us take in Java. Same example. Java. Yes, Java program. Java program. Java program dot in place of ex is a dot class file. No exe file gets a dot class. Java program dot class. Yes, dot class file. Java program dot class file prepared on Windows OS. Prepared on Windows OS. Then it contains parts. It contains parts. Yes, bytecode, not binary codes. Bytecode for Java program. Bytecode for Java program means is a dot class file. Extension dot class. So bytecode for Java program. Next bytecode. Yes, bytecode. Yes, bytecode for Java library. Like a serial Java's library. Java library. See, Java library also developed in Java. I mean, that also in dot class files. Java library also in the form of dot class files. Java library in the form of dot class file. Yes, your Java program in the form of dot class file. Java library also. Java library also in dot class file. Everything is dot class file. See, your program is dot class file here. Java library also dot class file. So bytecode for Java program plus bytecode for Java library. Bytecode for Java library. That's it. No OS library. No, it won't link. It won't link. Okay. So your Java program code. Next, Java library also developed in Java. Java library also developed in Java. So it is a pure Java program. Okay. Yes, it is a pure Java program. Just it is a yes. It is a pure Java program. It's a pure Java program. It's a pure Java program. Java program in bytecode formats. In bytecode formats. Bytecode formats. In bytecode. It's a pure Java program. Okay, Java dot class. Yes, it's a pure Java program. Okay, see, this is your dot class file that is linked to predefined dot class file. The dot class file and your dot both are linking. Both linking your dot class file and predefined library dot class. Both dot class file linking, generating a result dot class. Generating a result dot class. That result dot class contains only Java program, no OS library. Dot class file. Yes, dot class file. Dot class file. Dot class file. Yes, dot class file. Yes, you don't link it to dot class file. Don't link it to yes OS library. Don't link it to OS library. Don't link it to OS library. That's dot class file. Yes, there's no link with OS library. Dot class file don't have any OS library. So dot class file don't have any OS library. Okay, fine. Now, suppose for example here, tested dot class file, prepared. Yes, prepared on Windows OS. Okay, Windows OS or anyways. Tested dot class file prepared on anyways. Yes, you don't have any waste library. You don't have waste library. You don't have waste library. You don't have waste library. Yes, maybe anyways. Tested dot class file prepared on anyways here. You don't have waste library. Okay. Now these tested dot class are running at different platforms. How it's working. Tested dot class. Now let us take different platforms. Like a C language, here also let us take different platforms. Here's different platforms. Java. For Java's different platforms. Okay. Not tested dot class file. So tested dot class file. Test dot class moving on to Windows OS. Yes, now tested dot class. tested dot class. So tested dot class, tested dot class, tested dot class, tested dot class. Okay. Now tested dot class are placed on this Windows platform. Can I run it directly here? No, we can't run. Reason here. Yes, every program file has to link with OS library. Without linking, cannot run. It has to link compulsory here. Every program, yes, every program, see this. Every program has to link with OS library, otherwise cannot run. It has to link compulsory. It has to link. Once linked, it can communicate with hardware components to communicate with it. See, in order to communicate with the hardware here, this dot class should link with OS library, but not linked. How it execute? No, it can't run. Dot class file cannot run directly here. Yes, exe file you can run because all are linked with OS library. Exe file all are linked with OS library, so it can run directly here. But dot class file don't have a link, so dot class file cannot run. Yes, now this dot class file. So dot class file placing an Windows OS. After placing in Windows OS, this dot class file has to link with Windows OS library. Who will link it? Who will link it? This tested dot class file has to link with Windows OS library. Tested dot class file placed on Windows OS. Placed on Windows OS. After placing an Windows OS here, this dot class has to link with Windows OS library. Who will link it? For linking purpose between your dot class file and Windows OS, one more layer comes. Now one more layer comes here. So one more layer come to picture here. One more layer between dot class file, okay, and Windows OS library. One more layer comes. What is that layer? Yes, anyone can guess it. What is that layer here? One more now Java. One more layer comes here. One more layer comes. One more layer comes. What is that layer? One more layer comes. What is that layer? Yes, not Java library. Java library already is there. Tested dot class connects your Java program plus Java library already here it's there. Okay, one more comes here. One more comes. That is nothing but JVM. JVM. Yes, of course, Java interpreter. Yes, Mohan Datta. Okay, fine. Correct. Java interpreter. Yes, Java interpreter next will list. Java interpreter. Okay, correct. You are right. Okay. Now JVM comes. Yes, Java interpreter is a part of JVM. Java interpreter is a part of JVM. Now JVM will come to picture. Okay. Now JVM come to picture. JVM come to picture. Now what happens here? So first of all, tested dot class file moving to Windows OS. After moving to Windows OS here, now this tested dot class file taken by the JVM. That JVM links to Windows OS library. So once linked with Windows OS library, then execution, then getting outputs. Okay. Now let us take another platform. Yes, same thing, another platform. Windows platform. Next, Linux platform. In Linux platform, what happens? Linux platform. Now Linux base. So Linux base, okay, Linux base. Okay. Yes, with Linux library. With Linux library. Linux base with Linux library. Now here what happens here? Same test dot class. See, same test dot class. Same test dot class. Already prepared dot class. Same dot class file moving at Linux base. After moving at Linux base here, now this dot class file taking with the Linux JVM and links to Linux library. Once linked communicates with the hardware components. That's it here. Okay. Same thing, another platform. Suppose Unix platform. Unix platform. Unix platform. Yes, Unix base. Yes, Unix base. Then Unix library here. Unix library. Unix library. Unix platform, Unix library. Unix library. Now this JVM taking dot class, that Unix based JVM. So this JVM taking dot class file, JVM taking dot class file and links to Unix based library. So once linked with OS library, then communicates with the hardware components. That's it. Now what is happening here? Dot class is free from OS library. Dot class file don't have any OS library. Dot class is a plain Java program. Dot class is a plain Java program. Okay. So here when dot class file is moving to Windows OS, Windows JVM means Java Virtual Machine. JVM stands for Java Virtual Machine. Java Virtual Machine. Java Virtual Machine taking test.class file links to Windows OS library. Suppose same .class file if it is moving on to Linux OS, Linux JVM taking .class links to Linux OS library. Suppose same .class moving on to Unix OS, Unix JVM taking .class links to Unix library. So what is happening here? That link changes. Link is changing, right? If it is Windows OS, yes, linking to Windows OS. So if it is Linux OS, link it to Linux OS library. So depends on ways. Depends on ways that link changes for dynamical linking. This is called dynamical linking here. Java dot class file dynamically linking with OS library depends on ways. Depends on ways here that link changes. Since linking dynamically, it's a independent platform. That's it. Okay. See, previously exe file statically linking. Exe file is a statically linking. Okay. It means fixed. Once linked, that is fixed. That link will not change. That is dependent. But here link dynamically changing. Dynamical means runtime. Runtime that link changes. Depends on ways that link changes. If it is Windows based, linking with Windows based. If it is Linux based, linking with Linux based. If it is Unix based, linking with Unix based. Dynamically that link changes. Since linking dynamically, it's an independent platform. Yes, who will link it? JVM. JVM takes care of linking your dot class to yes current ways. Depends on ways. Depends on ways here. JVM. JVM takes care of linking. JVM takes care of linking. Okay. Windows JVM taking dot class file link to Windows OS library. Linux JVM taking dot class links to Linux OS library here. Yes, depends on ways that link changes. Depends on ways link changes. Okay. So the link is dynamically. It's happening dynamically. Since happening dynamically, it's an independent platform. Yes. How Java made us independent platform? Reason. Yes. Java dot class file links with OS library dynamically. Depends on ways that link changes. Since that link is changing here, it's an independent of OS. That's it. That is the reason behind of this. Next, one more thing here. Doubt here. JVM, is it part of OS? Windows JVM, Linux JVM, Unix JVM, is it part of OS? No, that is not a part of. JVM is not a part of OS. Then how can you get JVM? Java should be installed. JDK software should be installed here. So once JDK installed, you're getting JVM. Here JDK installation. Once Java installed, getting JVM. JVM is a part of JDK. JVM is a part of JDK. Yes, to get this JVM, we have to install the JDK. JDK on Windows OS, JDK on Linux OS, JDK on Unix OS. JDK should be installed. Java Development Kit, JDK, Java Development Kit. The JDK should be installed on every OS. Otherwise, you cannot. So JVM required. For the purpose of JVM, you have to install JDK. That's it here. Next, one more important point here. Java program dot transfer is independent platform, but JVM is OS dependent. Java program is a independent platform, independent of OS. Try to remember this point, very, very important point here. Java program is a independent of OS, but JVM is a OS dependent. JVM is a OS dependent. Reason, yes, JVM developed in C++. JVM developed in C++. Okay, JVM developed in C++. See, behind of Java program, C++ code will be running. Yes, that also when working with Java programs, practically also. Okay, today at 6 o'clock batch. Yes, same topic expanded. Yes, behind of Java program. This is some Java program I have developed. Yes, C++ code. How C++ code will create object like this pointer creating C++ this pointer, C++ this pointer. This is a pointer in C++. That pointer is that C++. That how that working here. Yes, see every program behind of Java program, C++ code will working here. C++ code. Okay. C++, not C. C++. JVM. JVM developed in C++. JVM developed in C++. Okay. Yes. If it is C++ program is for that exe file. C++ exe means it's a OS dependent. JVM is a C++exe. Yes, JVM.exe. JVM is a .exe. JVM is a .exe file means is a yes. JVM.exe means OS dependent. JVM. 1 second. JVM C drive program files Java JDK in JDK yes bin yes here Java. See this application means what exe file. This is exe file. JVM it's exe file. Application means exe. Just now I showed right. It's exe file. Application means exe file. Properties. Yes, it's exe. Exe. Okay. Platform SE binary here. A platform dependent SE library here. This is okay. SE means standardization. Standardization library here. This binary file. Exe file. Okay. So JVM is a exe file. JVM is exe file. Okay. So here Windows JVM, Linux JVM, and Unix JVM. The JVM changes from OS to OS. JVM is not same here. Yes, here Java program is independent of platform, but JVM is OS dependent. Reason it's a exe file developed in C++. If it is exe file, OS dependent. Okay. Now here JVM is exe file, OS dependent. Since JVM is OS dependent here, JDK also OS dependent. Okay, same JDK you can't install for different operations. Same JDK you can't use for different operations. Different operation, different JDK required. Reason JDK contains one JVM. JDK contains JVM. That JVM is OS dependent. Since JVM is a OS dependent, since JVM is OS dependent, JDK also OS dependent. Let me show that JDK. JDK. So downloading JDK. While downloading JDK, downloads JDK 1.8. JDK. JDK download. See this. JDK from the Oracle Corporation. JDK from the Oracle Corporation. See this. JDK for Linux OS. JDK for Mac OS. JDK for Solaris. JDK for Windows OS. See that different JDK slides like this. The different JDKs. Different JDK for different operations. JDK is OS dependent. JDK is a OS dependent. JDK is a OS dependent because of JVM. Okay, JVM is a OS dependent. Okay, see, Windows JVM is having knowledge of Windows OS, so it can link test.class file to Windows OS. Linux JVM is having knowledge for Linux OS. See, this JVM developed for Windows OS, this JVM developed for Linux OS, this JVM developed for Unix OS. GRE will discuss next page. Difference between JVM, GRE, JDK. Differences JVM, JDK, GRE. The differences we'll discuss next. We have separate topic and that JVM, GRE, JDK. The differences we'll discuss. Wait. Okay. Now here, see, JVM is a yes, JVM. Yes, Windows JVM is having knowledge of Windows OS library. So it can link a tested.class to Windows OS library here. Yes, Linux JVM is having knowledge of Linux OS, then it can link to Linux OS. By having knowledge, what that means here? Windows JVM is having knowledge of Windows OS. How? Yes, that point. How we can justify that point here? Yes, Windows JVM is having knowledge of Windows OS. How we can justify that point here? See, what is exe file? Exe file linked with OS library. That means this Windows JVM already linked with Windows OS library. That means this is known about Windows library. Okay. See, Windows JVM already linked with Windows OS library. This exe file contains Windows OS library. Since JVM is having Windows OS library, it knows about Windows library, so it can link with Windows OS library. Already inside of this JVM, Windows library is available. Inside this JVM, Windows Linux library available. Inside of this JVM, Unix library is available. So these JVMs are this JVM already built in with Windows OS library. JVM already built in with Windows OS library. So it's having knowledge. With that knowledge, it can communicate with Windows OS. That's it here. This is what is happening in Java. Okay. So how Java made us independent platform? Reason here. Yes. Java dot class for dynamically links with OS library by the JVM at runtime. Dynamical linking. Since Java program dynamical linking to OS here, it's a independent of OS. That is for JVM. So JVM takes care of all of these things. That's all about independent platform. I think everyone is clear, right? Yes, about independent platform. Is it clear? Yes, independent. What's the difference between dot class file and dot exe file? 1 second. Exe file dot class file differences. Let us see the differences here. Yes. See here about exe file discussed, about dot class file discussed. Now let us compare these two. Comparison. 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 Exe file dot class file comparison. See this. First difference. See exe file. Yes, we need JVM every time compulsory. That point also now covering here. See exe file. It's a binary code file. It's a binary code file. It's a system understandable language. Dot class file. Dot class file. It's a bytecode file. JVM understandable language. Binary code is a processor understandable language. Bytecode is a JVM understandable language. That is .exe and .class file. First difference. Next difference. See this. Next difference. Exe file. It contains program codes plus software library plus OS library. Dot class. Purely Java program. Purely Java program. Don't have any OS library. It contains bytecode for Java program plus bytecode for Java library. Purely Java program. Bytecode for Java program, bytecode for Java library. That's it. Yes, here OS library also. That is next difference. Next difference. See, exe file is a prepared file for specific operation. OS specific. Exe file is a OS specific because linked with OS library. It contains OS library. Exe file is a prepared file for specific OS. Dot class file is not a prepared file. It don't have any OS library. It's not OS specific. Dot class is not OS specific. Okay. Yes. Next point. Next point. OS library. Yes, OS library statically linking with exe file. Yes, here OS library dynamically linking with dot class file at runtime. OS library dynamically linking with dot class file at runtime. Okay. Yes. Next difference. Okay. See, exe file is already prepared one. Already prepared directly executes. Already prepared means already converted into binary code, already linked with OS library, everything already prepared one. Okay, prepared one directly executes. But dot class is not a prepared file. Dot class is not a prepared file. After moving on to OS, after moving on to OS, JVM prepares as per current OS. That's it. Depending on OS, that link changes. Okay, so dot class is not a prepared file. After moving on to OS, as per current OS, prepares. That is dot class. So next, exe file executes faster than dot class file. Exe file executes faster than dot class. Reason, exe file already binary code file, already linked, everything prepared, already prepared directly execution. No runtime preparation, no runtime direct execution. But what is dot class for preparing at runtime? It executes slowly. Preparing at runtime. The dot class file, dot class bytecode. Bytecode converts into binary code. That binary code links with OS library. See, who will do that? At runtime, bytecode converting into binary code. 1 second. At runtime, what happens here? Bytecode converting into binary codes and links with OS library. Yes, see this. This is total complete JVM. In JVM, this is interpreter. Now this is interpreter. JVM, this is interpreter. JVM interpreter. Look at JVM interpreter. See dot class file. Loading into memory. Class loader. Bytecode file. Next interpreter. Given interpreter. Class file given to interpreter. So interpreter taking dot class file. Yes, converting into binary code. After converting into binary code, links to runtime environments that OS library. So interpreter taking at runtime as a part of JVM. JVM means is a very big one. JVM contains many programs working parallelly. As a part of JVM, there is an interpreter. JVM contains one interpreter. That interpreter taking your dot class file, converting it to binary code and links to OS library. Converting and linking happening at runtime. Converting and linking happening at runtime. Since happening at runtime, slowly executes. Slowly executes here. Slowly executes. Okay, dot class file executes slowly than the exe file. It's already prepared. Since already prepared, that executes faster. Exe file executes faster than dot class file. Exe file executes faster. Okay. Yes. Next difference. Next difference. Next difference. To run the exe file, application software not required to install. What does mean here? Suppose this is Unix, Linux base. Yes, here Linux. See, Linux 1, Linux 2, Linux 3, Linux 4. There are four Linux computers are there in my machine. 4 Linux computers. Okay, first Linux. On the first Linux, C software installed. GCC means C language software. The C compiler installed. Okay, so developed a C program. After installing software, developed. Yes, got one. After getting this exe file, that exe file can move to another Linux base. Similar Linux base. Direct you can execute. On second Linux base, again C software not necessary. Yes, installing C software not necessary. To run the exe file, C software not necessary. Only for development C software required. Only for development purpose, exe file generating. Okay, once exe file generated, C software not all required. Take that exe file, place into another similar Linux base and execute directly here. C software not all required because exe file is a already prepared file. Oh, at runtime, yes. 1 second. Exe file is a already prepared file. So runtime C software again not necessary. Not necessary here. It's not necessary. But Java is required because JVM. Because of JVM. To run the Java dot class for JDK required. To run dot class for compulsory JDK should be installed on OS here. Otherwise cannot. Because of JVM required. To run the dot class file everywhere. Whenever, yes, everywhere compulsory you have to install JDK. Okay. So we need JVM to run dot class file everywhere. How to get JVM? JDK. Okay. Yes, to run dot class file, JDK should be installed. JDK should be installed here. Exe file, that is not necessary. That's it. That is difference. Okay. Exe file discussed, dot class file discussed. Okay. Now once you compare, now it's clear topic. Exe file versus compare. Yes, dot class file. Once you compare, things becomes easy here. It becomes clear here, right? This is difference between exe file dot class file. Just 1 second, you guys. Same independent platform search in Google. How much information you get it? Just a matter of 2 or 3 lines, get information, you get it. Next, what's the difference between exe file dot class file? Just try for this difference in Google. Only 2 lines. Exe file is OS dependent, dot class file is independent of platform. Only that information, not more than that. Yes, no one will use this much of information. What is exe exactly? What is dot class exactly here? What is happening at runtime? Okay, how OS is working? Okay, yes, how OS is working? What is OS behavior? OS behavior. Okay, next exe file, how it's generating here? How dot class was generating? These concepts no one will explain. I'm sure. Not only sure, it's my challenge. No trainer will explain for you. Yes, no trainer, even no website will explain these concepts. Suppose who are worked on embedded C, they can explain. So worked on embedded C, later switch to Java. Who worked on embedded C, after later switch to Java, that guy can explain. That guy can explain here. Okay, to understand this topic, to explain this topic, lot of knowledge required. Like embedded C knowledge required, OS knowledge required, Java knowledge required, JVM knowledge required, lot of skills required. Otherwise, it's not easy to explain here. Okay, it's not easy to explain this. Because of I have all these skills. Because of that reason, yes, very clearly explained. See, to explain independent of platforms, 1 second, I'll tell you one thing. Just one point, right? Independent of platform. Most of the trainers simply they will say that independent of platform is independent of operating system. Java program running on any OS, same program running on any OS. Reason behind of the JVM. Only just matter of 5 minutes I will explain about this point. Okay, Java is independent of platform, is independent of operating system. Behind of this JVM. JVM makes the Java program as independent of platform. Only these 2 points they will explain. They will go to next. That's it. But I have taken 2 classes. Yesterday is a prerequisite for the today class. Yesterday, why started from basics? Started with voice. What is voice expand? What is interpreter expand? What is compiler expand? What is exe file expand? What is dot class file expand? After explaining all of this, finally, this point presented. Okay, to present these points, yes, yesterday 1.5 hour topic and today 1.5 hour topic. 3 hours explained. Yeah, that is my experience. That's all. That's the difference between me and other trainers. Okay. Yes. Any doubts? Yeah, that's all about this one here. See here, when you explaining programming also, I'll explain very clearly. Back end, what is happening back end? Yes, JVM, how it is working here. Behind of Java program, how JVM is working, how JVM is responding here, how TPFS code is running. All that concepts in programming itself I'll explain. Okay. The thing is here, problem with my classes, you must have the patience. You patience, listening patiently listening is very, very important here. Okay. You must have the patience to understand my classes. You must have the patience to listen to my classes here. Okay. Yes, who is having patience, they can get ultimate knowledge, no doubt. I can give maximum. See, my experience is more than the industry. 20 years, more than industry. In industry also, no Java developer have this much of knowledge. My experience is more than the Google. Even Google also will not give that much of information, that much of concepts. I'll explain more than the Google. Okay, Google can, when you're searching for anything, Google, little bit information get it, but this much of information you can't get. Okay, see, from the first day, I'm giving lot of information. On every topic, lot of information I'm giving here. For starting, yes, language, system understandable language. For that reason, I explain about generation of computers. After explaining generation, what is a present generation of computer? After that, next move to Java. So before coming to Java, all the prerequisites. What is OS? What is exe file? What is dot class file? So what is interpreter? What is compiler? Yes, all this. Yes, this kind of knowledge. Yes, you must have that knowledge, that kind of knowledge. Okay. If you have that knowledge here, then easy to answer any question interviews here. Here, my intention is my student should answer every question. Yes, when you facing any interview here, yes, you should answer every question. Yes, even you must have the knowledge more than the interviewer. Suppose interviewer, somebody is taking interview. Yes, more than that guy you have the knowledge. You must have that knowledge. That is my intention. Okay. So what I promised, yes, after, by the time of finishing course, you'll get minimum 3 to 4 years of experience. That level I'll train you. By the time of finishing course, you'll be in a position to put up minimum 3 to 4 years of experience. Like a experienced guy, you can present in the interviews. Like experienced guy, you can present interviews. Okay, that level I'll explain. Don't worry. Okay, yeah. Brief idea on embedded C. Yeah, definitely. Yes, next class I'll explain definitely. Yes. Yeah, that's all for today. That's all for today. Yes, please wait. Don't leave. Don't leave. So next tomorrow class about, yes, tomorrow class Java installation. Tomorrow class Java installation. Yes, 1 second for your batch. Yes, WhatsApp group already. This is my WhatsApp number 8179189 Yes, please share your details, your name and Gmail. These two things enough. See, Already communication is going on. Yes, 8 p.m. See, communication is going on. Yes. See, yesterday's class here shared here. That link, yesterday's class session, you can watch here. Watch it here. Just you can download, watch it. Easy down. Yes, from the WhatsApp may not be working. Download into your system and watch it. Yesterday's session, third session. Yeah, this is this session. Yes, the previous sessions. Yes, session 1, session 2, and session 3. Session 1. Yes, this is a 15th session, 16th session, 15th, 16th, and 17th. Yeah, today's session, I'll share it. Okay, that is the benefit of WhatsApp. That's the benefit of WhatsApp here. So just you download and you share it. Download, just you watch it here. Okay. Next, drive WhatsApp created. Yes, I'll give the drive access. I'll give the drive access. Drive. Yeah, 8 p.m. See, 8 p.m. So this 1 to 3. 3 recordings available here. Today recording also I'll upload here. Yes. I'll give the access. Drive level access. I'll give drive level access. You can. Yes, tomorrow I'll give the drive level access. Okay. Tomorrow I can give the drive level access. Next, one more. Tomorrow topic is installing Java. Yes. Tomorrow class, Java installation topic. Tomorrow, yes, Java installation. Yes, take this. Still anyone, yes, not submitted, take this one. Yes, I'll share class document. Tomorrow I'll share it. Class documents and softwares. Everything tomorrow I'll share it 100%. Okay. Yes, I'll share to your Gmail ID. My WhatsApp number, please, anyone pending are there, please share your Gmail ID and your name. I can add to the group here so that easy to communicate with you. Okay. Yes, please take this number. If anyone still not yet submitted here, yes, if not submitted here, please share. I'll add to group. Just I will add to group. So once you are a member of group, easy to communicate with you. Okay. Yeah, that's all. Yeah, that's all for today. So thank you guys. See you tomorrow. Tomorrow same link. Yes, tomorrow installation topic. Java installation, Eclipse setup, application. Tomorrow starting programming, installation and programming. Okay, that's all. So thank you guys. Have a great night. Have a great night. See you tomorrow.